So our learning goal is still the same as it was yesterday. I can solve a system of equations using the substitution method. The second method that we've learned, what was our first method again? Solving by graphing. And when we're using the substitution method, that's an algebraic method, that if we did also use the graphing method, it should still get us the same solution. It should still lead us to the same ordered pair. So today what's going to be, what we're going to introduce that will be different is, I want you to underline this right here. You may need to solve one of the equations for a variable before solving the substitution. So in other words, when you look at the equations, neither of them will have an x alone or a y alone, so you need to make that happen. Here's what I find happens with students. They don't really take the time to critically think through what would be the best one to work with, and which variable should I solve that one for. They just dive in, pick one, and say, okay, I'm going to solve this one for x, and then they end up with some fractions involved in it, and it makes it kind of miserable when you have to go and substitute with those fractions, and you just make life much harder for yourself than you need to. So you're going to have to, make some, take the time to make a good decision about which equation and which variable would probably make the most sense. Because you have actually 4 options. Each equation has an x and a y in it. So 2 x's, 2 y's, we've got 4 choices we really could make. Notice what they did in this one. That our system is y minus x equals 4 and 2x plus 3y equals 27. They could have solved the first one for y, which is what they did. They could have solved the first one for x, which is not what they did, but they could have. They could have taken that second one and said, okay, I'm going to solve this one for x. And then they could have taken that second one and said, I'm going to solve this one for y. If they would have worked with the second one, especially the second one, if you choose that one, you're going to end up with some fractions that are going to then have to be substituted back into that other one and have to go through all that extra work. So they took the first equation and solved it for y. Make a good decision right here before you even start. Okay? So I'll let you just use that as an example for you to, another example you would have in your notes, and we'll just go right to work. Okay, today we are going to check our answers. Okay? We're solving an equation for x or y, and so if we need to go back to the original system of equations and check our answer and make sure it's right. That's on all the ones like this. If it's a word problem, we'll do our checking a little bit differently. Okay? So what do you think we could do in number 1? What are some choices we have? Because we don't have either equation set equal to just x or to just y. So what are some of the choices we can make here? So we could solve the second one for y, because Avery says you could subtract 2x from both sides on the second one, which would get the y alone. So that's one option. That's another option we have. Let's explore all of our options. Cameron, give me another option.
Subtract x on both sides from the first one.
Okay, so it appears that what you're going to try to do is take the first one and get it solved for y. Would that require one more step though? If we took the first one and we subtracted x from both sides, would that require one more step to get y alone? Yeah, because that's a negative y, so then that would basically involve 2 steps. So we could do that. That's an option though. What's another option we have? What's another option we have up there? Austin?
Add y for the top one.
Okay, we can solve the first one for x, we can add y to both sides, and that would just be a 1 step, wouldn't it? Okay, and then we still have a 4th option, maybe not the best option, but we could also do what? Solve the second equation for x instead of y. So we really have 4 options here. Let's take that first equation and let's solve it for, so right underneath here, let's say, solve first equation for x. In other words, that means get x alone. So we're going to write down our first equation. We're going to rename it so that it's usable for our substitution method. What are we going to do to both sides, Chase?
Subtract x.
No. We're solving it for x. Add y. Thanks for helping Chase out. X equals -3 plus y. Okay, this is, so basically what we've done now is we have renamed this equation. Okay, so let's just go up here beside it and put that we have now x equals -3 plus y. So what we've done is what their step one was up above. Our step one is different. That's kind of like, step one is when we start substituting. Okay, so their step one was getting the equation solved first of all for either an x or a y. And we're just going to continue with our steps from yesterday now. So we got one of them solved, so now we would take we now know that x can be replaced with -3 plus y in our other equation. So we're going to substitute into, so we're going to work with our 2x plus y equals 12. And we're going to substitute our -3 plus y in for that x. And again, I said yesterday, if after you've done your substitution step, you still have both x's and y's in your equation, that's a problem. So now we just have y's involved, so we can solve this equation now for y. So go ahead and get this equation solved for y. After you do some simplifying first. I get that y equals 6. How about you? Same? Okay. So now we can go and get our x value. Now at this point, we're not checking yet. At this point, you get to use, you have 3 options. You have 3 places you could go and solve for x. You have the original name for the first equation, you have the new name for the first equation, or you have the second equation. Which one do you think would be probably the most efficient one to use? The new name, right? Okay, so let's go to step number 2, and let's use the new name that we have. Because trust me, if we already named it wrong, we've already gotten the wrong y value anyway, so we're going to catch that in our check problem. So we're going to put our 6 in for our y, and we're going to say our x value is 3. Okay, so now we have our x value. So in step number 3, we write our ordered pair answer. Our ordered pair answer is 3. Our x value is 3. Our y value is 6. There's our solution. Okay, today we are going to do check problems. Where are we going to do the check problems? Back in the original equations, not that new name, back where we started. So, check. We are checking ordered pair 3, 6 in both equations as they started. So we have the x minus y equals -3, and we have the 2x plus y equals 12. So we'll put our x and y values in and work our way down until we can't do any more. And see that it checks in that one. And it checks in the other one. So we can feel pretty confident that we have the correct ordered pair where these 2 lines will intersect on the graph. So you are going to do check problems to the left to verify that you have the correct answer. You cannot check in the new name because, of course, if you did it wrong, if you renamed it incorrectly, or you substituted incorrectly, or whatever, it's going to possibly check out and mislead you that you have the correct solution. Any questions? Okay, let's go to the back side and let's take a look at that one and make a good math consumer decision which we should do, which equation we should get solved for x or for y. So start thinking about it. If I solve this one for x, what are some of the steps I would have to do and what would happen? So like this is like mental math time. You know, all you people that don't want to show me work, this would be the mental math time. If I solve the first equation for x, would that be pretty? If I solve the first equation for y, would that be pretty? Second equation, maybe. So which one do you think? Anybody got a suggestion for us? I think it would, which one would work out pretty nicely for us? Benton?
Solve for x in either equation.
In either equation. Okay, you get to pick then, Benton. Which one? Should we do it in the second equation just to be different this time?
Sure.
Okay, thanks. Okay, so we're going to put solve second equation. And I kind of like the idea of that because we can get those numbers smaller then when we rename it. Solve the second equation for x. Why would we not want to solve that second equation for y? Or even the first equation for y? Anybody think they know, Benton, why would we not want to do the y's?
Because you'd have to divide the entire equation by 16, 4, and that doesn't go too well for x.
Yeah, we're going to end up with, because our 2 would have to get divided by 4 in the first one, our 2x would have to get divided by 4. Is that an integer? No, that's going to be a fraction, 1/2. In the second one, we'd have to divide the 4x by 16, and then we'd end up with a 1/4. So we don't want to choose y's, we want to choose x's. So let's take that 4x, subtract 16y, and get it solved for x and yx, because then we don't have to deal again with that fraction. So we're going to add 16y to both sides. And dividing every piece by 4 is really nice. We are going to get integers and get our numbers smaller. So our new name is x equals 8 plus 4y, or at least in my rule. Is it in yours? Yeah? Got the new name for it? Okay. Now that we know that x is equivalent to 8 plus 4y, now we can take that 8 plus 4y, put it into the other equation for x. So step number 1, we're going to use equation, or 2x minus 4y equals 20. We have to go into the other equation, substituting our equivalent x. And as tempting as it would be right now to say, oh, there's a plus 4y in those parentheses and there's a minus 4y outside those parentheses, they'll cancel each other out. Can we do that? No, that 4y in the parentheses is attached to a multiplication problem. So we have to simplify this before we can do anything. We have to do that distributive property. So go ahead and get this one solved for y after you get it simplified. And hopefully you're getting y equals 1. Or you need to tell me where I went wrong. Okay, so we need to go move on to step 2 where we're going to find our x. And which equation do we use? The first one, the second one's new name. Second one's new name. Yeah, it's always going to make sense to use the new named one for this step. You can use the others, nothing says you can't, but you probably will create less work for yourself if you choose this one. And step number 3, our solution is 12, 1. These two lines would intersect on the graph at ordered pair 12, 1. Okay, check problem. And where do we do our check problem? In the original for both of them. So the first one we didn't mess with at all. That one was 2x minus 4y equals 20. And the other one we did, but it started out as 4x minus 16y equals 32. Is that what it is? Somebody help me out? Yeah? Okay. So let's get our subbing in. We got 12 to put in for x. 1 to put in for y. And we don't just do that and then magically say it checks. We say, oh, 2 times 12 is 24. 4 times 1 is 4. 24 take away 4 is 20. You will not convince me on assessments that your check, you can somehow, sometimes I wonder how, but somehow get the correct solution, but then when you check them, no, other way around. You get the incorrect solution, but then when you check them, they check out. Because you force them to check out. You pretend that they're checking out. Check problems are designed to help us catch that we probably got the wrong solution and we should go back and figure out what went wrong. 4 times 12 is? 48. 16 times 1 is 16. 48 take away 16.
30.
Is legitimately or because we want it to be? It's legitimately that, okay. So we can say it checks out. So some of you are way too skimpy in your check problems and they won't count. Make them useful. Anybody have any questions? We're going to do a word problem. What do you suppose is, after you read through the word problem, what is the first thing you're going to need to do? Describe x and y. Yeah, what is x going to represent and what is y going to represent? So make a decision right now. Read through it and see what we're solving for. And let's decide what could we let our x and our y represent in this problem. Read it to yourself. You got it on your paper there. Okay. What is it that, typically all you gotta do is look for is what are they asking us to find? And that's what your x and y would represent. So what should x represent, or what could x represent? Okay, you don't like x. What could y represent? You like y. Okay, Benton.
Y could represent the cost per DVD.
Okay. And then what would x represent?
Cost of a CD.
Yeah, so one of them has to represent the cost of CD, the other one has to represent the cost of the DVD. How can I be so convinced of that? It says determine the cost. of a used CD and a used DVD. You know what? It's telling me right there. X then is going to be the cost per CD. Is that what we decided? And Y is the cost per DVD. Now we can set up our system of equations. Kate bought 3 used CDs, 1 used DVD. Then her friend Joel bought 2 CDs and 2 used DVDs, and then Kate spent $20 and Joel spent $22. What do you think we could do here? Any ideas? We're going to do lots of this tomorrow, so come on, be brave. What could we do here? We know how many each of them bought. We know how much money each of them spent. We need 2 equations, 2 people. Benton.
3x plus y equals 20.
3x plus, and why is it just a y because they just bought 1? So it's really a 1y, but we could just write it as a y. Okay, and equals how much?
20.
20. So this is representing what? What is this really representing, Benton? Which person?
Kate.
Kate. Kate bought 3 CDs at X dollars a piece. She bought 1 DVD at Y dollars a piece. And altogether, apparently, she spent $20. Is that right? Okay, who's the other person? Joel? Okay, what's Joel's equation then? Riley? Okay, so this tells me, without me looking at the problem, that Joel bought 2 CDs, 1 DVD, and he spent $22.
No. He bought 2 DVDs.
So what would need to change?
Your Y value.
So we needed 2 in front of our Y? Now, do we agree? So did Joel buy 2 CDs, he bought 2 DVDs, and he spent $22? Yeah? Okay, I think we're ready then? Okay, so we are going to need one of these equations solved for X or for Y because neither of them are. So we're going to solve which one? The first or the second one, and for which variable? Make this painless, you guys. There's only one really good choice here that, really saves us a whole lot of work. Which one? Austin?
Solve for Y.
Yeah, take that first one, solve the first equation for Y. All it's going to take is moving that 3x. So we're going to solve the first equation for Y. Now in your homework you don't have to write this out every time, you can just go do it, but it's a good idea maybe to just, while you're learning this, make it so that you can tell what you're actually doing. So 3x plus y equals 20, all we got to do is subtract 3x from both sides, and we will have our y alone. We will have renamed that first equation as y equals 20 minus 3x. And now we can take our 20 minus 3x and replace the y in the other equation with it. So step number 1, 2x plus 2y equals 22. We got to use that equation. Oops, I'm not substituting in for x, I'm subbing in for y. Okay, let's figure out the cost of a DVD because we're solving for y, or excuse me, the cost of a CD because we're solving for x first, it looks like. Oh, so much for getting integer answers all the time. Does this DVD have to sell, or CD, excuse me, does this CD have to sell for an integer value? No. So you should end up with x equals a negative divided by a negative is a positive, and we should end up with 4. You can take 4 4s out of 18 with 2 left over, so that is 4.5, which is since we're talking about money, cost, let's put it as 4.5 or 4.50, it doesn't matter either way, because remember this is how much a CD costs. So instead of using it as a mixed number, let's use it as a decimal because it is a nice decimal. Okay, step number 2, we got to go find our y value. Let's use our new name. Y equals 20 minus 3x. Now I'm just going to work with 4.5 for a bit. $4.50 3 times. How much is that? What is it? $13.50. Yeah, 13.5. $20 take away $13.50 is what, Colin? Yeah. Yeah, with a little help from the side. Here we got $6.50. There's our y value. Now, we don't, this is a word problem. In step 3, instead of writing it as an ordered pair, we write what?
Words.
Words in a sentence, that's right. So, the cost per CD is how much? How much are the CDs?
$4.50.
Yep, $4.50. And the cost per DVD is the $6.50. Okay, I would at least like you to do a mental math check on these. In other words, go back to the original problem and say, does it make sense? So, now that we know how much the CDs cost and how much the DVDs cost, we can go back and say, Kate bought 3 used CDs. 3 times $4.50 is $13.50. And she bought 1 DVD at $6.50. $13.50 plus $6.50 is $20. Did she spend $20? Yes. Okay, Joel bought 2 of each. He bought 2 CDs at $4.50 each. That's how much? $9. And he bought 2 DVDs at $6.50 each. That's how much money? $13. What's 9 plus 13? 22. Is that how much money Joel spent?
Yes.
Okay, so we just did just a quick check to see if our answers make sense back to the problem. Okay? So for those, you can do mental math checks. So take the time to do it. Okay? Questions? Okay, then you are ready to get started on your homework. You have 9 problems again. But this time you're doing check problems for the ones that aren't word problems. Maybe you need more than 9 problems. Just the front row here. You wouldn't want to do that to the rest of your